A mould having dimensions 100 mm into 90 mm into 20 mm is filled with a molten metal through a gate as shown in the figure. So in this figure is given a gating system, and there is a pouring basin and sprue, and also given a mould cavity. Here mould cavity is filled with the molten metal through the gating system, and also given dimensions. The height is okay for a height h and cross sectional area a. The mould filling time is t1. Suppose in case 1, suppose height of the height of the gating system, height is h1 is equal to h, and cross sectional area a1 is equal to a. What is the mould filling time? Mould filling time Tm is equal to T1. Mould filling time Tm is equal to T1. Okay. Next, the height is now quadrupled. So here quadrupled means height is now quadrupled. Quadrupled means 4 times. 4 times of initial height. So case 2. What is case 2 here? Now case 2 is height is quadrupled. So h2 is equal to 4 times of initial height, 4h. Okay, na? 4 times of initial height. Quadrupled means 4 times and meaning. Next, cross sectional area is halved. So cross sectional area is halved. Halved means half. Okay, na? So initial area by 2. Okay, na? Half of the initial area. Halved and half of the initial area. Now what is the mould filling time? Now mould filling time is corresponding filling time is T2. Mould filling time is equal to Tm is equal to now T2. Okay, na? For dimensions h and a, height h and cross sectional area a, mould filling time T1. For dimensions 4h and a by 2, mould filling time T2. T1, T2. Okay. So at last evaluate ratio of T2 by T1. Find ratio of T2 by T1. We have to find ratio of T2 by T1. Before that, what is the formula for mould filling time? Mould filling time Tm is equal to volume of mould cavity by flow rate. Volume of mould cavity by flow rate. So this is the formula for mould filling time. Mould filling time Tm. So mould filling time Tm is equal to formula volume of mould cavity by flow rate. So volume of mould cavity, remember volume of mould cavity is constant. Okay, na? V is constant. And what is Q? Flow rate. What is the formula for flow rate? Area into velocity. A into small v. Okay, na? Velocity of molten metal. Now Tm is equal to V by A into, A means cross section area, into, what is the velocity formula? Root over 2gh. V is equal to root over 2gh. Velocity of molten metal is equal to root over 2gh. Now let us find T2. So T2 is equal to, using this formula, T2 is equal to V for volume of mould cavity, constant. So A2, so in place of here write A2 is root over 2gh2. Now what is T1? T1 is equal to V by, in place of A1 root over 2gh1, right? Now replace corresponding values. V is constant. A2, so A2 is equal to what? A2 is equal to A by 2. Okay, na? Here cross sectional area is halved. So A2 is equal to A by 2. Now 2 root over 2z. H2 is equal to what? H2 is equal to 4h. Here H2 is equal to how much? 4h. So similarly T1 is equal to V by A1, in place of A1, A root over 2gh1 equal to h. Now T2 is equal to, let us simplify T2. T2 is equal to V by A by 2 into root over 2gh 2gh into 4 into 4. We know that what is the value of root over 4? Root 4 value 2. So V by A by 2 into 2 into root over 2gh. Root over 2gh. Okay. So root 4 value 2. So 2 get cancelled. You will get V by A root over 2gh. Now T2 by T1 is equal to what? T2 by T1 is equal to T2 is equal to what? V by A into root over 2gh by what is T1? T1 is equal to same V by A into root over 2gh. So numerator and denominator get cancelled. Then what is the ratio? T2 by T1 is equal to 1. Therefore ratio of mold filling times T2 by T1 is equal to 1.